Today we will be reviewing your pre-algebra skills that you will be needing for Algebra 1 in order to be successful this year. We're going to start with the absolute value concept. Absolute value is the distance that a number is from 0 on a number line. For example, the absolute value bars are those long bars with numbers inside. So if I take the absolute value of -2, that is telling me that -2 is 2 spaces from 0, so the answer is 2. Another example has the negative sign on the outside with absolute value of -7 inside. Right? You have to do the absolute value bars first. So -7 is 7 spaces from 0, and because there's a negative on the outside, the answer is -7. This is the only instance when you will have a negative answer for an absolute value problem. These are not double signs, even though they look like they might be, because of the bars. The bars act as a wall, and you cannot break through the wall. Okay, so do not circle double signs between the outside of the bars and the inside of the bars. And then if I take a positive number, like the absolute value of 6, all that is asking or telling me that is 6 spaces from 0, so the answer is 6. Okay, the next thing we want to talk about are the integer rules, and we've touched on this with a warm-up in class as well, so we just need to go over them and make sure we know the difference between them. For adding or subtracting, I'm asking that you eliminate double signs first, rewrite your problem, and then go from there. So for the examples, I will walk you through what step 3 is describing. If we have -4 plus parentheses -2, double signs are when you have a sign with two signs with no number between them. So you'll see sign, number, sign, sign, number. This plus and this minus are double signs. So I'm going to rewrite it to say -4 minus 2. Now I have to look at my numbers and decide, are they like signs or unlike signs? This is -4 and the number -2. So both numbers are considered negative numbers. That means I'm going to add the numbers. 4 plus 2 makes 6. Because both numbers are negative, my answer will be negative. So the answer is -6. For the next one, I have -10 plus 3. There are no double signs because it goes sign, number, so I don't have to worry about that. And the signs are different. There's a negative number and a positive number. So I need to subtract the numbers this time. 10 take away 3 is going to leave me with 7. Because 10 is the bigger number and it's a negative number, the answer is -7. For the third example, if I have -5 minus -8, I do have double signs here, so my two negatives are going to rewrite to be a positive, so the problem changes to -5 plus 8. I see that I have different signs, which means I'm going to subtract. So 8 take away 5 is 3. Because 8 is the bigger number and it's a positive number, my answer stays +3. With multiplying and dividing, the signs are a little easier to remember because there's not as many rules around them. If the signs are the same, your answer will always be positive. If the signs are different, your answer will always be negative. So for instance, if we have -16 divided by 2, a negative divided by a positive is going to be a negative. So the answer is -8. Okay, if I have -4 times -7, okay, that shows you multiplication because there's no other sign between the two parentheses. A negative times a negative is a positive. 4 times 7 makes 28. And then the third one is going to deal with exponents, and exponents are a form of multiplication, so we have to be careful here too. This is telling you that -3 in parentheses is being multiplied times itself 3 times. And when you do this, you want to take and do 2 numbers at a time and then get your answer with the third number. -3 times -3, 2 negatives make a positive, 3 times 3 is 9. Then you want to bring down the second -3 and now multiply 9 times -3. Positive times negative is negative, 9 times 3 is 27, so your answer is 27. With these integer rules, there are faces that I like to use that will help you remember what to do with them. And some of you may have seen these faces before. Others of you, this might be a brand new concept that you find useful and helpful. Okay, so I'm going to explain how these faces work in terms of these integer rules. All right, your eyes are the signs. So when your eyes are open, they're plus signs, and that means that you're awake, and that's relatively a good thing. So that's positive, and that makes you happy. Okay. Well, when you're asleep, your eyes are closed, and we generally like to be asleep, so that's a positive thing. That makes us happy too. Okay. But when somebody hits us in the eye and one eye is swollen shut and the other eye is open, that's not such a good thing. We're not very happy. So that's a negative thing, and that makes us sad. Okay. When the left eye heals and opens up and then the right eye gets hit, again, we're not happy. So that makes us sad, and that's a negative thing. The nose gives away everything in these faces. If you look at it, right, in addition, when you add two positives, All right, you add the numbers. When you take two negative numbers, you're going to add them together to get your answer. When you have different signs, a positive and a negative, you're going to subtract the numbers, right? And same thing with a positive and a negative. In multiplying and dividing, it tells you what the sign of your answer is. So two positives will make a positive answer, two negatives make a positive answer, and then different signs will make a negative answer. So these faces have a lot of information in them. You just have to know how to use them and what they mean. But the nose is the giveaway on those. Okay, the next thing we want to talk about is to review fractions, and we are going to go through all operations with fractions. Right? So the first thing we're going to talk about is adding or subtracting fractions. If you have fractions, I am asking that you change them to improper first, if needed, and then to go forth with the process from there. With adding and subtracting, you must find a common denominator if it is needed, right? And change it to a new one, and then proceed with adding or subtracting. So the example that I want to show you will display what I'm talking about. Okay, now this example also has double signs, so we want to take care of that when we're rewriting our problem. There are no mixed numbers, so we don't have to worry about step one. We do need a common denominator. 6 and 2 are not the same number, so we need to find the lowest number that both of them can divide into, and it happens to be 6. So we're going to make our fractions have a 6 on the bottom, and the sign in the middle is going to be a minus sign now. Because the 1/6 already has a 6 on the bottom, the 1 stays the number on top. But we need to adjust with the 1/2. And you always need to ask yourself, what can I multiply 2 by to get to the 6? Well, 2 times 3 makes 6, so then that means I must multiply 1 times 3 to get 6. So that'll give me my new fraction of 3 over 6. To get to your answer, the 6 will stay the denominator, and you add or subtract the numerator, whatever it says to do. So 1 minus 3 gives you negative 2. Remember that you must always reduce your final fraction to get full credit for it. So if you divide by 2, your final answer will be negative 1/3. Okay. The next thing we're going to take a look at is multiplying fractions. Okay. And with multiplying fractions, same thing applies first. You still must change to improper. And then we're going to talk about cross-reducing diagonally, and then multiplying numerator to numerator, denominator to denominator. And then once again, you must always reduce those fractions. Right, so let me show you by example what I'm talking about with this process. 4 2/3 times negative 2 1/2. Right, we do have mixed numbers in this example, so the first thing I want to review with you is how to convert to improper. Remember, you take the denominator times the whole number and add the numerator. So 3 times 4 is 12, plus 2 gives you 14 over 3. Times, keep the negative sign, and don't add it into your calculations. So you're going to do 2 times 2 is 4 plus 1, and that gives you 5 over 2, but the negative sign stays with the 5. All right, so now you're going to look at reducing diagonally. The 3 and the 5 have nothing that can reduce by it. They're going to stay 3 and 5. But the 2 and the 14 can be divided by the same number. 2 divided by 2 is going to leave you with a 1. 14 divided by 2 is going to leave you with a 7. And now you're ready to multiply straight across. 7 times negative 5 is negative 35, and 3 times 1 is 3. You can convert this to a mixed number if you wish to, but in Algebra 1, we operate with improper fractions all the time. So if you leave it improper, you're actually better off than if you convert it to a mixed number, because eventually you'd have to go back anyway. So just leave it at improper as long as it's reduced and move on. For dividing fractions, you had to know how to multiply before you can divide. Right? I like to use the letter CCF to help you remember what you're supposed to do, and those letters stand for copy, change, flip. Right? There may be other acronyms that you were taught in other grades that you can use as well, but those are mine. The first thing, again, change to improper, and then you're going to copy the first fraction, change the sign to multiply, and then flip or do the reciprocal of the second one, and then continue with your multiplication steps. So the example I'd like to show you that'll show you all of this is right here. 7/18 divided by negative 14 over 15. Right? There are no mixed numbers, so step one is not needed. You are going to copy the first fraction, 7/18, change divide to multiply, and flip the second fraction. When you flip it, just keep the negative attached to the 14. We'll make sure it carries through in our answer when we get done. Right, so now you're ready to reduce diagonally. So both diagonals can actually be reduced. We'll take the 7 and the 14 first. 7 and 14 can be divided by 7. 7 divided by 7 is 1. Negative 14 divided by 7 is negative 2. Go ahead and travel the negative 2 or the negative with the 2 so that you always have the negative sign with you in your answer. Going the other way, 15 and 18 can be divided by 3. So 15 divided by 3 is 5. 18 divided by 3 is 6. Now you're ready to multiply straight across. 1 times 5 is going to give you 5, and 6 times negative 2 is going to give you negative 12. You can write your answer 5 over negative 12, or You can write -5 over +12. It does not matter. The negative is what is known as a floater. As long as you only have one of them, it doesn't matter what level it's on. I prefer that it be up top because I tend to lose it if it's not up top, but you can put it either place as long as you don't have it in both spots. All right, one of the last topics we're going to deal with is order of operations, which you guys should be very familiar with over the course of the years. You may even remember PEMDAS along the way, and that it has the L and the R added to it recently. Okay, so there are some ways to remember that. Right? I have some issues with PEMDAS. I don't agree with the first letter being a P, and here's why. Your first letter is always centered around your grouping symbols. If you remember that the P stands for parentheses, you're ignoring all the other grouping symbols it could possibly be. So it's kind of a false image there. Right? So yes, you need parentheses because that is one of the types of grouping symbols. But there are three others that we need to also recognize. The boxy looking things are known as your brackets. The squiggly looking things are known as your braces. And then if you remember back at the very beginning of this sheet, the long bars known as your absolute value bars. These are all types of grouping symbols, and any problem that has them in it, whatever's inside must be done first before you go outside of the problem. Then you can go to exponents. Multiplying, dividing is from left to right. Adding and subtracting is also from left to right. Right, so the example that I have will demonstrate some of these, but not all of them. So we have 24 divided by 6 plus 2 to the third power times 4. Right, there are no grouping symbols in this problem, so we're going to go straight to exponents. Do one piece at a time. Try not to do too much, or you could jeopardize the answer. 24 divided by 6, then 2 to the third is going to turn into 8 times 4. Okay, so now we have divide and multiply in the same sentence that's left, so we have to go from left to right. So dividing must come first. 24 divided by 6 is 4, plus 8 times 4. Now do your multiplying, so you have 4 plus 32, and the final answer comes out being 36. Do not write equals 36. We are not solving an equation. We are evaluating an expression. Right? So there is no equal sign in these answers. Right? So try to train yourself otherwise. The last topic kind of hinges off of order of operations, and that's evaluating an algebraic expression. The only difference between the two is that this one has letters that you have to replace, and order of operations is basically numerical. You are using the substitution property. You are replacing the variables with a given number and then following those order of operations. Right, so I'm going to give you a pretty basic one just to show you what I'm talking about. We need to evaluate 3m plus 5 if m equals -7. Right? Train yourself now from day one to replace every variable with a negative number by using parentheses around it. If you don't, later on in the year, you're going to find yourself with some not so good grades because that negative sign is going to catch you. So put -7 in parentheses in place of that letter. Then continue with your order of operations. So multiplying comes first. That's -21 plus 5. You have two different signs. You're going to subtract your numbers. 21 take away 5 is 16. Because 21 is bigger, your 16 is going to be a negative answer. So the answer comes out being -16. Come off over here to the left and make yourself a reminder. Okay? Anytime you replace a variable, which is a letter, with a negative number, always use parentheses. Okay? And I promise you, if you train yourself that way, you will cause yourself to have much better results on all of your assessments throughout this year and any other math class that you do. Right? We will practice all of these skills in class over the next couple of days. Right? So make sure that you are well versed with them and that you understand what each one is about.